everyone knows, I'm Associate Professor T.S. Dr. Hasliza Rahim from Advanced Communication Engineering, Head of Bioelectromagnetics Research Group and also Research Fellow for the ACE from Faculty of Electronic Engineering. Okay, so this is our outline for today. I'm going to cover, since that this webinar is going to introduce, giving a brief introduction of the Scilab, what is Scilabs and what Scilabs can do and so on. So these are the outlines of this webinar session. Okay, so I can regard this as a short workshop lah. Okay, and it also contain some technical part for the Scilab. Okay, so we will go through this thing later on. Okay, so let me introduce about the Scilab. So what is Scilabs actually? Scilab is a scientific software package for technical computing, and these are the main features: high-level programming. So as we know that high-level programming, for example, C, C++, and so on. So the Scilab is actually the simplification of this C and also C++ programming. So it is very easy for you to do programming, computation, automated computation using the Scilab, because this is actually the alternative for the MATLAB. So I believe that from now on we need to gradually move towards the open source software, because of some reason lah. I will explain later on. Okay, so interpreter, data environment. So you can do a lot of stuff using the Scilab, transparent data types. Similar with the MATLAB, actually, large collection of built-in primitive functions. So you have functions to help you out to compute the signal processing, image processing, machine learning, and so on. A suite of Scilab-coded function toolbox and also integrated. And why people like about Scilab? Okay, so the main advantage of the Scilab, you can port a MATLAB toolbox to the Scilab. So you can actually take the toolbox from the MATLAB and import into the Scilab. And it also have a multi-function of built-in functions and also a lot of toolbox, which will be helping you in various applications. Like I said before, for the artificial intelligence, signal processing, control system, and so on. And also another main feature for the Scilab is XCOS. So this is similar to the Simulink in the MATLAB. So SciCos is a visual system modeling tool, letting the user visually build the system that can be dynamically simulated. So if you do not like to do the coding, you can use the XCOS using the block diagram and connect, and you can simulate to get the result. Okay, so XCOS is a free alternative to the MathWorks Simulink. So you do not have to worry about paying for the license and so on. And yeah, and this is about ethics lah. Okay, so ethics. So if you are using the crack software, okay, crack software, so actually it is unethical. So why not we use something which is free and then have various application that you can explore and use for the teaching, especially for the teaching, and also it can be used for the research. Yes, it is free, so you do not have to pay to use the Scilab. Okay. Okay, so we go briefly into the history of the Scilab. So it's actually started way back in 1980s, Blaise to Basels. Okay, so these are the founders of the Scilab. Okay, and then from 1990 to 2009, it becomes a Scilab consortium. So it is growing into the version 1 until version 5.1, and after that, it keeps upgrading from year to year, version 5.2 to version 5.5 5. It means that throughout this route, it keep on adding the toolbox, the functions, and so on, and it becomes more useful. And yeah, we can say that quite resembling the MATLAB. And last up until today, the latest version is actually version 6.1.0. Okay. Okay, Octave. Octave is actually one of the open source software founders. So it's already joining the Scilab uh, to grow the Scilab. Okay, okay. Why we need to use it, especially for the government, school, and also university, lower IT. Okay, so let's say if we have to buy the MATLAB license, okay, MATLAB license, let's say the MATLAB license costs you around 4,000, and you have 7 labs that contains 70 pieces per lab, and it's actually you need to pay 1.96 millions just to buy the MATLAB license. But yeah, we do not want to invest a lot of money uh, to buy the MATLAB license. Okay, yes, we know that MATLAB is superb, but it may put you in the poor house. Okay, because we need to spend millions of ringgit to buy. And also MATLAB is the storage to install the MATLAB is getting higher. So now for the latest version of the MATLAB, the MATLAB installation is around 20 gig, 20 gig. Okay, compared to Scilab, it is much lower lah. Okay, so these are the main feature of the Scilab. Uh, it contains the XCOS. We know already about the XCOS. This is a simulation toolbox. And it is a metric base. So of course, when you want to do Scilab, this is very important lah. Okay, because it works with the MATLAB. It works with the matrix foundation. Okay, and a lot of features that you can find to support the Scilab, and also it has a automatic modules management system that support the extended toolbox in the Scilab. Okay, so we will go briefly to the features of the Scilabs. This is introduction to all of you. Okay, so what actually Scilab can do? You can do 2D, 3D graphic animation, linear algebra, sparse matrices, polynomials, rational function. Then you can do the plotting like on my right hand side, interpolation, approximation. This is differential equation solvers, SCOS, optimization, differential, non-differentiable optimization, signal processing, statistic, machine learning, neural networks. Now, Scilab already have a neural network, deep learning, and so on, image processing, and computer vision. So it becomes more useful, and the toolbox are growing towards the industry 4.0. Okay, so Scilab has been built using a number of external libraries. And then Scilab works on most Unix system. If you're using the Linux, it works, and also it supports the Windows. So you can install, go to the website and install. So I will show you on how to download the Scilab. And it comes with the open source code. Okay, so you can Google, find the open source, and through that, it will be much easier for you to start your coding for your application, especially your application directly, and do the computation. And it also has English manual. Okay, so these are the glimpse on the application for the communication engineering. Okay, so why I choose communication engineering? So since that we are targeting for the communication engineering. That's why. So from here, if you go to this website, okay, scilab.org tutorials, you can find a lot of features that support by the Scilab. Computer vision, control system, education, finite element modeling, machine learning, numerical analysis, openeering, optimization, signal processing, statistic, system modeling. Okay, so these are actually new features in the Scilab. So before this, I have started using the Scilab since 2011, and all of these features are not there yet. So they are growing year by year and adding all of these application tools to the user. And yeah, in year 2011, I have published, I have started using the Scilab for the teaching actually, for the teaching subject signals and systems. It's a year 2 course, and publish the laboratory module using the Scilab. So we have fully converted the coding, the MATLAB coding to the Scilab. So what I want to stress now is actually you can use the Scilabs. Okay, you can encourage the student to use the Scilabs for the communication engineering courses especially. And in fact, if you are exploring, if you are teaching in the computer networks, it also can be used. Okay, so here if we take a look at finite element modeling, so this is one of the field for the communication engineering. So we are using this for the electromagnetics computational. So these are the example. Okay. Okay, so what you can do is for 2D plotting, exterior acoustic with boundary element method, model reduction on chemical vapor deposition reactor, open source. This one, optimization genetic algorithm, surrogate models, and DOE and mesh morphing. Okay. Yeah, so you can go to the website and look at it. Okay, so since that we know that Scilab is very useful for the computation, so how can we apply the Scilab? Okay, so I give example in the communication engineering field lah, since that I'm one of the researchers in this area. Okay, so what you can do is if you need to calculate the dielectric measurement computation for the two main parameter, complex permittivity and also complex permeability, you can perform this calculation using the Scilab. Okay, I know that in the CST, especially CST software, you can get directly the values of the permittivity and permeability. But if you are using the rectangular two-port waveguide, so that this value, permittivity and permeability, must be calculated using the computational software. So Scilab is one of the best option to do this. Okay. Without paying anything lah. Okay, so we are trying to avoid the cracked version of the MATLAB lah. So why don't we use the Scilab? Okay, and second one is the calculation for the absorption rate of metamaterial microwave absorber. So if you are doing a simulation for the metamaterial microwave absorber, you cannot get directly the absorption rate value from the CST. CST is a computer simulation technology software that are mainly used by our researchers. So you need a computational software and you can use a Scilab to do this computation. Okay. The third one is a MIMO antenna parameters such as envelope correlation coefficient, ECC, diversity gain, and also mean effective gain. Okay, so I know that most of us are using the Excel. Okay, Excel to calculate these three main parameters for the MIMO antenna. However, if you have a large data set, So it will become tedious for us to process all the data. Okay, so what you can do is to automate all the processing for the MIMO antenna parameters. You can use also the Scilab. And another application for the communication is you can, for the propagation, okay, you can do path loss computation. So these are the example on how the formula of the path loss, uh, and to get the values of the path loss, you can compute using the Scilab. Okay, so as I said before, like MIMO antenna parameters, if you have a large data set of the propagation, means that you have hundreds, thousands of data. Okay, so it will be hard for you to process using the Excel. Okay, that's why I process this data and compute all the parameters for the path loss using the Scilab. Okay, and to get, we can see the red crossing here, the blue circle here. So these are actually the values that have been calculated using the Scilab. Okay, so now we want to get started with the Scilab. Okay, so how are we going to use the Scilab? Okay, so first of all, you need to download the Scilab lah. Okay, and download the latest version up until now is 6.1.0, and then run follow steps. So it's quite easy. Just go to this website. You can do now. Go to this website and download. So you can choose. If you're using the Windows, you can choose 64 or 32. Okay, so since that my laptop is 64, so I choose a 64 version. And to start the Scilab, just double click on the Scilab icon on the PC desktop. Okay, or go to start all program Scilab. Okay. Okay, so we need to install the Scilab first lah. Okay. Alright, so once you already install the Scilab, you can see the console. Okay. This is the pin. Okay, display GUI of the Scilab, and the empty window is a command window, and you have a variable browser, and also you have a command history. So the feature does looks like MATLAB lah, a bit. Okay. So I think there will be no problem for you to migrate from MATLAB to Scilab. Okay. Okay, so what is command window? Command window is used to enter variables and run function and sci files. The command windows is where you can interact with Scilab directly. So this is where you need to write the coding and so on. Then you can execute and run and execute the codes. Okay. All right. So in the Scilab console, you can find um, four items here, four tabs: file, edit, control, application. Okay, so what is file? File contain the execute, open a file, load environment, save environment, current working directory, page setup, print, and quit. Okay, and also there are few more features under the file tab here that you can take a look in the Scilab. Okay, all right. Okay, so for the edit, you have a cut, paste, empty clipboard, and select all. You have a control, resume, abort, interaction, interrupt. Okay, for the application, this is where if you want to use the Xcos, you can go to the application, click on this, and click on the Xcos editor. If you need to write the coding using the SciPad, you can go to the editor, MATLAB to Scilab translator also we have. So you can also try to translate the MATLAB codes to the Scilab codes. Okay. All right. And In Scilab, we have a help browser. Okay, help browser, help windows that contain a lot of built-in function here, very useful function, elementary function, FFTW, and so on, a genetic algorithm. There are a lot more actually. So you can open the help browser and take a look at the all of the built-in function there. You have also the data structure and so on, and it has manuals here. What are the functions that contains in the elementary functions such as absolute value, arc sign, arc cos, arc sign, tan, and so on. Okay, useful function for the mathematical calculation. Okay, and then how to launch the SciPad? Go to this icon. Okay, when you go to this icon, it will pop up into the side notes, and here you can write down the codes of the Scilab. Okay, so these are actually the basic, uh, the basic things that you have to know about the Scilab. Okay, because you want to write the codes. So where are you going to write the codes? You have to know lah. Okay, and here we always use for the side notes to write codes for our own function. Okay, so that after we write the function here, we can call in the command window there. Call the function and and run. Okay, so the expression in Scilab, you have four main expression: variables, numbers, operators, and also function. Okay, variables. So what are the variables? So of course, if you want to compute values, output values, you have to declare the input variables and also output variables. Okay, so how to declare the variables? Highlight of the variable's name can be up to 25 characters long. It can contain letters, digits, and underscore character. Must begin with a letter and is case sensitive. So, and then one more important things that need to be taken care of is you have to avoid using names of built-in function, such as built-in function of the Scilab. Okay, inside the Scilab, you cannot use this because it will give you error, conflict of interest lah. Okay, so because you already have Scilab already have this function, then you want to use it, so it will be it will get conflicted. Okay, and semicolon, sorry, suppress a command line. Yeah, similar with the MATLAB. Yeah, default variable. So if you do not declare the output variable, it will show you answer A and S. Okay, so we do not have a name for that output variable. Okay, so how about numbers? So numbers are very important in the Scilab. It uses conventional decimal notation. Okay, so this is where the MATLAB do not have, because if you type in 25 in the Scilab, okay, the answer will be 25 point. Okay, so point here means that the decimal. So if you have any decimal numbers, it will written as this. Okay, so do not get apa ni? Do not get confused about this lah. Okay, so it is a Scilab style to put point. In fact, this is the real numbers. Okay, and able to use normal scientific notation and imaginary numbers. It also support the imaginary numbers, so it means that you can do the complex numbers calculation. Okay, so these are the basic operator that you have to know lah. Okay, so if you want to do the codings in the Scilab, you have to know the symbols. Okay, plus, minus. So actually this symbol is similar with the MATLAB. So if you are familiar with the MATLAB, so of course the same symbols are being used in the Scilab. Okay, so for the bottom one is a matrix operator lah. Okay. All right. Function. Okay. So built-in function. So what are the samples of the function in the Scilab. Okay, so since it supports the mathematical computation, you have to know lah, how to use the built-in function. So you can go to the help browser there and find out what are the function inside uh, the Scilab. Okay, so I give you a simple example. So if you need to calculate for the square root of 64, so you just call the function of sqrt, then it will give you the answer of 8. Okay, I know that square root, okay, square root is heavily used in the engineering field. So Scilab supports most of the mathematical functions for the engineering. So do not worry about that. Okay, so these are the basic function calling syntax of the built-in function. So you have to know on how to do this coding lah. Okay. On the left hand side, you need to declare the output variable. Okay. Declare. So output variable, you do not have to declare in terms of integer, decimal, floating points, and so on. You just put the variable name equals to function name inside the Scilab and the input. Okay, so this is how the basic functions calling syntax. Okay, that you can use in the Scilab. Okay, so some of the useful functions in Scilab, we have elementary functions, sum, prod, square root, diagonal, cos, max, round, sign off. FFT also we have a fast Fourier transform for those who would like to do the digital signal processing, image processing, and so on. Rounding, sorting, specific matrices, linear algebra, polynomials, random numbers, characters, strings. Okay. So these are the useful functions that can be used for the engineering, especially for the communication and also computer engineering. Okay, so how we use a Scilab as calculator. So these are the brief example on to use a Scilab as a calculator. And the second example is for the imaginary calculation. So you can try out this by typing this function in the Scilab. Okay, so the only different things Scilab with the MATLAB is if you're using a special characters like imaginary I, pi, and so on, you need to put percent. Okay, percentage symbol here. Okay, so if you do not put percentage symbol, it will give you errors. So you have to note where to put the percentage symbols. Okay, so semicolon. So these are the basic syntax on how to do the right coding for the Scilab. Okay, so from my experience, I can say that Scilab's the way on how we write the codes for the Scilab is quite similar with the MATLAB. So if you are expert in MATLAB, so for sure you can successfully write or use the Scilabs. Okay, so this is a special contents lah, the one that I show you just now. Okay, this one is a special constant. For the special constant, yeah, have to use a percentage. So you have to note on this part. Okay, protected and cannot be delayed. Okay, so we have how many special constant here? You have 8. Okay, so 8. Right. Trigonometric constant, constant representing the precision of the machine, not a number, infinity, polynomials as Boolean, true, false, and so on. Okay. Okay. So these are the example lah. Okay. So example of the exercises. Okay, so you can actually do the coding in the Scilab. Okay, coding in the Scilab to do the computation of this question. So this is what we call as a variable manipulation. introduction to the coding for the variable manipulation. Okay, so let's say you have a table price 256.95, chair price 89.99. So you need to evaluate the cost of 2 tables and 8 chairs. So how are you going to write this code? In the Scilab? Okay, and then you need to add 5.5% service tax and round the total cost to the nearest ringgit. Retry number 1, 2, 3 and find the total cost in ringgit for 100 tables and 1,120 chairs. Okay, so these are the answer lah. Okay, so first of all we need to declare the input variables and values, table, price, chair, and to calculate for the answers number 1, so you just multiply with the input variable by 2 and also by 8 for the chair, and for the total to find the added tax just equals to 1.055. So this is 5.5%. So multiply by this variable, and to do the round just call the built-in function of round, and the total values when you add up into 100 tables and 1120 chair. So you need to recalculate with the new values and you will get the answers. Okay, so as simple as that. Okay, so this is a basic coding to perform the calculation computation in Scilab. All right. Yeah, loading and saving variables. So how to load and save the variable? Loading and saving means that you would like to save the computed output, or you want to export the file into the Scilab. Okay, so this is how you do it lah. Okay. If you have a variable A, B, C, then you want to save this in the text file. So you can save as a give a name, but do not forget the column here. Okay, that. So it will be saved in the current directory where you point your directory lah. Okay, where you choose your directory in the console of the Scilab. And when you want to load the variable, so this is how you do the loading. Okay, so how we manage the variable in the Scilab? Okay, so this is actually the previous version. What you can see for the latest version, here we have a variable. We have a variable just like a MATLAB. Let's say, okay, so here you have in terms of matrices lah. Okay, so since A is only 2, so if you have a matrix or vector and so on, it will fill up all of this column. Okay, so quite simple for this one and useful. If you want to check your answers and so on, you can go directly to the variable browsers. And if you want to delete, you just delete. Or if you need to modify, you can do modification lah. Okay, just put a number here. Save. Okay. All right. Okay. Okay. So since that we know that Scilabs work like a MATLAB, and the foundation of the Scilab, it works in vectors and matrices, you have to know about the fundamentals of the matrix. Okay, so before you go deep into your application like machine learning, fuzzy logic, neural networks, and so on, this or image processing, computer vision, finite element method, you have to know about how to handle, how to do the coding for the matrix. Because from my experience, um, the mistake that you always do when you do the coding in the MATLAB or in the Scilab is you don't know how to do the correct operation for the matrix. Okay, so sometimes what we declare matrix is um, not in the same size and so on. So these are very very important actually. Okay. Okay, so um, the working principle of the matrices in the Scilab is similar. I would say similar. Okay, similar with the MATLAB. Okay, I know that in the image processing or in the machine learning, we are using a lot of metrics, correct? Or artificial intelligence optimization and so on, n-dimensional metrics. One dimensional, two dimensional, and three dimensional. And the metrics are very important when it comes to the n dimensional matrix. Okay, so how do the Scilab read the matrix? So we will start with a row first and go to the column. Okay. Uh, Okay, matrix element can be either numbers or characters. Yeah, you can use characters or numbers like this. Okay, this is what we call as a rectangular matrix. For the scala, 1 by 1 array lah. Okay, for the vector, m by 1 array or 1 by n array. Okay, for the matrix, you have m by n. So these are the matrix lah. If you have only uh, you have only you have only one row but many columns, so that's what we call as a vector. Okay, so you need I believe that all of you are expert with the matrix lah, but I just want to briefly explain about this. Okay. Okay, so let's say we want to extract this value. So to extract this value, the name of this matrix, the variable for this matrix is A. So how to extract the value? So you just call A and bracket, put the position lah, row first and then second column. Okay. Or you can address this as A bracket 17. Okay. These numbers is according to row element. Okay. Sorry. Column element. Okay, 1, 2, 3, 4, 5, 6, 7. It will goes by the uh, goes downwards. Okay, so how do you specify this 5 by 5 matrix A in Scilab? Okay, so these are important lah. Okay. So like this only. A equals to put lah 4 space 10, 1, 6, 2, 8, then and so on, and semicolon. Okay. Or if you do not want to declare like this, you can declare in horizontal mode. Okay. So, but you need to put the semicolon for each row. Okay. So this is how you declare the matrix. If you have a matrix lah. Yeah, in image processing, they are using a lot of matrices. I think for the pixel processing, right? The pre-processing, the data processing. Okay, so more on vectors, on how these are the function, the useful function to operate for the vectors. If you want to declare the vectors, here start double colon and then if you want to put the in interval, initial value, double colon, increment, double colon, final value. And to create linearly spaced row vector, you can use built-in function, line space, start and numbers. And for the log space, logarithmic values, you use function log space, start and numbers. And to get the length of the vectors, call the function of length. Okay, so this is similar with MATLAB. Okay, transpose, if you need to do the transpose function, just use the apostrophe. Okay. Okay, so how do we work with the arrays? Okay, so we have some more times here. Okay, array concatenation means that we want to join this array together lah. Okay, how we do this? Okay, so let's say you have how many arrays here? You have 2 by 2, 2 by 2 matrix. Okay, you have 2 by 2 matrix P1, P2, and P3. So you want to join this together to become like this lah. Okay, to become like this. And you can use a function of cat. Cat stands for concatenation. Okay, and specify the dimension and put the values of the small matrix here. Okay, so how do we create the arrays? So these are the basic uh, syntax or basic code to create the arrays. Okay, create the matrix shown below by using the below vector notation. First and second row with colon separator, third row with line space command. Okay, so you need to use two ways here. So the first one is using the traditional declaration of the uh, matrix, and second using the line space command. Okay, so these are the answer lah. Okay, answer only one line. Okay, the coding is only one line to display this result. Okay, so colon separator. So 1 double colon 3 double colon 3 13. Okay, because we want to compute for the first row. Okay, first row here from 1 until 13, and this is separated by 3, right? Okay, because 1 to 4 is 3, 4 to 7 is 3, so this is constantly increased by 3. So we use this function. Okay, this function here. Okay, this function, not line space. Line space is a little bit line space. Yes, you can use line space also. Okay, line space or colon separator lah. Okay, like this lah. Okay, so this the second row is decreasing value. Okay, decreasing from 72 to 66. So it means that it decreased by 6. Okay, 66 to 60. So you can put like this lah. Specify the start number 72, the end number, and the interval between each elements here, and to use the space. Okay, right. So that's about it. Okay, and this is a special matrices, zeros. How you declare the zeros? Okay, so it will give you zero values for n by n matrix. Okay, so where do this very useful? We use this a lot, so many times in wireless communication. Why? Because we want to initialize the matrix. Okay, so when you do the initialization of the matrix, especially in wireless communication, in image processing, in computer vision or machine learning, so you can use this special function of the matrices in the Scilab. Zeros if you want to declare the rectangular matrix. So this is the first one is the square matrix. Second one is a rectangular matrix, n by n. And if you want to do the random numbers also, you can do. Okay. Okay, random number normally we use in artificial intelligence for the optimization. Okay, so we use a random number, a similar syntax for our meta-heuristic algorithm, sine cosine. Sine cosine is one of the powerful meta-heuristic for the optimization. So it's part of the artificial intelligence lah. And the eyes one. So if you want to initialize the matrix in for the values of ones. So this is how you call the function of the matrix. If you want to know the size of the matrix, so use the function of size. Okay. All right. Okay. Okay. So to work with the submatrix, okay, for the submatrix, you want to extract this element lah. Okay. So to extract this element, there are two ways. Okay. The first one is using the row and also the column. Okay. And another one is using the sequence numbers of column lah. Okay. By column. Okay. And we want to extract this. So this is also important actually. Important when you do matrix manipulation in application of wireless or in the propagation. So we always need to extract the submatrix, okay, to do the computation. So how we extract the last column of this matrix, okay? So there are three ways actually to do this extraction. Okay, the first one is the traditional way where you use uh, row and column. So from row 1 to 5, comma, column number 5. So it's quite easy. Okay, so what you have to do is you need to know the position where you want to extract. So if you want to extract the second column, so how you do that? From row 1 to row 5, column number 2. Okay, so as easy as that. Or, okay, you don't want to declare from row 1 to row 5. You don't want to declare, you just put the double dot. Double dot means that all rows. Okay, so remember that the first position inside the declaration to extract the matrix is for the row elements. Second one is the row position. Second one is the column position. Okay, and the last technique is using the column wise sequence, okay, from 21 to 25. But the red one, the red font is we normally do not do this lah. Okay, we always go for the row and column. Okay, so because it's quite hard for us to keep track the position in the column wise. Okay, so let's say you want to extract 2 by 2 at the position of row 4 and 5, column 2 and 3. So this is how you do it lah. Okay, so A bracket 4 to 5. So double column means 2. Okay, the range. So you need to specify. So let's say if you need to extract this. Okay, so it means that you extract all the row elements values and from column 2 to column 4. Okay, so simple lah. Okay, so these are more example of the column index. So you need to master this part lah. Okay, this is very important, very important for the large data set computation. So if you have hundreds of data, it's okay. But when the data set is getting bigger and bigger, like you have 100,000 of data. So all of this operation becomes very practical and handy and efficient. Okay, so you do not have to spend a lot of time doing manual using the Excel and so on. So you just do the coding and compute the result in the Scilab. Okay. Okay, indexing and so on. So I don't think that I need to go further. So it's a very basic So if you are familiar with the MATLAB, this is how the Scilab works for the array operation, array multiplication. So array multiplication is quite straightforward lah. Okay, so let's say you need to multiply the array element. Okay, the array element. So this is how you do it. So you need to declare the input array first. The input array and the values that you want to multiply, and you will get the answer. Okay, so for the matrix multiplication, this is how we do it. Okay. All right, for the systems of linear equations, we use this heavily in wireless communication, right? So before you go into complex mathematical expression, you have to, this is my advice lah, you have to master of this basic operation lah, for the arrays, for the matrix and so on. Okay, so this is the introduction lah on how to handle the linear equation. Linear equation. So let's say you have how many equation here? 3 equation, right? So we are going to solve this using the matrix. Okay, so that's why matrix becomes very useful. Okay, so how we extract it? On the left hand side, okay, the values of matrix is 1, 1, -1, -1, okay, so 2. So we need to extract all the coefficient for the input parameters of x1, x2, x3, okay. So if you take a look at here, x1 means that the coefficient is 1, okay. So for the second row is 2, 1 and 1, okay. The last row, the third row is you need to bring this to the left lah, okay, to make it balanced, because you have how many variables that you have here? You have 3 variables, right? Okay, so it needs to be ni lah, is a simple mathematics only. Okay, so bring here. So you have a coefficient of 1, -3 and +1, right? Okay. Sorry. Oh, sorry. No need to bring -1 here. So S1, but you do not have the variable of S2, so it means that 0. Okay, 0 and -3. Okay, and multiply by all of the variables and the answer for on the right hand side. Okay, right hand side 0, 1, -1. Okay, so it means that this is, the 3 by 3 matrix we declare as a A, and the variable is x, and the output is b. So x multiplied by a multiplied by x equals to b. Okay, so you declare, okay, this is how we extract the information and convert it to a matrix form to solve the linear equation. Okay, so linear equation can be found in many applications lah, such as wireless, what else? Wireless, communication, control system, right? Okay, control system, image processing. Yeah, I think machine learning also have. Yeah, in some part lah, some part of machine learning. Yeah, okay. Alright, so we need to declare the matrix of A, okay, from this 3 by 3 matrix, and the B, okay, so the B, okay, the what, 3 by 1, okay, 3 by 1, this is actually vector, okay, so B is vector. Okay, so to get the values, so we need to do the backslash lah. Okay, backslash is okay, to solve for this linear equation. Okay, alright. Okay, so sorry. Okay, so before we go, we finish this webinar. Okay, so before we finish this webinar, we will do some simple example case study, the depth study on how to compute uh, this value. Okay, the depth of a well. Okay, the depth of a well using the vector here. Okay, all right. It's quite hard. Quite hard. Okay. So everyone already installed the. Okay, we will do it together. Everyone already installed the Scilab? Install or not? Hello? Hello? Am I losing it? Okay. Everyone already installed the Scilab? No, eh? Oh, okay. No question so far? Do you have any question? So are you more confident to use the Scilab for the teaching, for the learning? Yeah, for the student, you can use the Scilab for the learning. So if your lecturers ask you to do assignments using any computational tools. Okay, yeah, of course, a lecturer will not ask you to do in MATLAB because we know that we have a very limited license for the MATLAB. So for my student, I always ask them to do the computation because I also teach digital signal processing. Okay, so I ask my student to do the computation for the DSP in Scilab. Okay, so it's quite challenging for the student lah. They need to explore, understand. If they have a basic background on the MATLAB, no problem. But if they do not have, so this technical introduction of the Scilab will become very useful to the student lah. For the lecturer, you can start do the migrating migrating from MATLAB to the Scilab. Okay, so for further exploration, you can go to Scilab website. Okay, so I will show you the Scilab website. Okay, so here is where you download. Okay, download because most of us are using the Windows, right? So you can download here. Okay, so it depends on your computer setting lah, Windows 64 or 32. So if you're using Windows 32, so you can click on this, it will start downloading, and you need to install the Scilab in your PC. Okay, so if you're using the Linux, okay, so you can click on this or here, it depends on your setting, computer ni lah computer punya system. Okay, and Mac. So for those who are using the Mac, Mac, PC or laptop. Okay, so you can use this. So it's actually support for 3 different platform. Okay. Tutorial. Okay. So tutorial for those who are very interested with the Scilab. Yes, from my very own experience, yeah, I have tried. As I said, I have tried Scilab. Actually, the person who introduced me to the Scilab is our uh, ex vice chancellor, Professor R. Badlisha. So he is the one who pushed me to go for the open source software because he is very focused. I mean, he is very interested with open source software, and he wants all of his lecturer at that time. He is the dean at that time. Wants to use the open source for the teaching. So that's why I'm motivated by him lah, and I explore this Scilab by myself, and also we also conduct a series of workshop with Bytecode at that time, 3T technology company for our lecturer to get used with the Scilab. So actually Scilab is not new. So we have been in this field 2000, how many years 10 years I can say 10 years 10 years already. So quite experienced. So I would like to encourage all of you, I mean students, lecturers, uh, researchers to start using the Scilab. Okay, we need to explore the Scilab lah. Okay, so if you want to use the Scilab for your own application based on your teaching courses or your research area, you can explore in this lah. Okay, so for the computer vision, you can go to here. Object recognition also you can find the source code for this one. You can try. Okay, since that I'm not in this field, but I know that a lot of you are doing this. So this one is supported under image processing design toolbox. Okay, so you see so many things. So at the beginning of the Scilab's growing, and 10 years ago, we do not have this actually. So you need to explore one by one. So it's quite hard at that time actually. Okay, and now a lot of people are interested with the Scilab, and in fact, the industry also moving towards the Scilab. So uh, yeah, so it means that students also have to know. Okay, we need to teach our student lah to use the Scilab. Okay, do not wait until I don't know few or 3 years, few more years. Okay, we need to start now. Okay, no, do not wait. Okay, so many things are cycles, block seasoning. You can explore on your own lah how we do this. I do not cover the cycles because it will take some more time. So but I think this is quite easy lah. Okay, and also you can uh, interface a Scilab with the Arduino using the cycles of coding. Okay, you can take a look at the function here for education. Yes, machine learning. Okay, so this one, a lot of researchers are applying the machine learning, no matter in what field, wireless, signal processing. In fact, I'm also doing the machine learning for the signal processing project, and also for my electromagnetic projects, machine learning. So we plan to use a Scilab lah as a platform to write the coding for the machine learning. That one is unsupervised machine learning. Okay, so deep learning image processing, you can do deep learning. Deep learnings are very popular nowadays because very effective lah on how to do the classification, right? Okay, understanding deep learning convolutional neural network. Okay, so the Scilab is getting more advanced now. Okay, more advanced. So why not we start lah. Okay, we need to explore on this part. Okay, alright. Okay, so we need to finish our what? Okay, our case study here. Okay, so are you ready? Can I get feedbacks lah from the participant lah. So are you feel convenient now? Are you feel more confidence to use Scilab now? Confident? Don't know.
Yes, doctor, we are confident.
Okay, good. Siapa yang tadi? Who are responding? Okay. Alright, very good. Okay, so now I hope that all of you install the Scilab because it's quite simple. It's only a few minutes to install compared to the MATLAB, because MATLAB you need to have a storage of 20 gig to install the MATLAB. Very big. So it takes 1 hour to 2 hours to install. But for the Scilab, only few minutes. I think 5 minutes to 10 minutes only. So it depends on your laptop lah. If your laptop is fast processing, I mean high RAMs, then it will be much faster. Okay. All right. Actually, Oh, I do not put. Okay. Okay, so let me go to. Wait, Okay. So if you take a look at here, how many lines that you have to solve this problem? Okay, case study, depth study, we want to do the computation. So for those who are in the field of antenna and propagation, you want to do the dielectric measurement parameters to get the complex permittivity per epsilon and also the mu. So this is how you do the coding lah. Okay, so very simple one. It's not that hard. Okay. So let me make it smaller lah. Okay, okay, alright. So we will go one by one lah. Okay, go one by one. Determine D for T. So means that we need to calculate the depth of a well. Okay, the depth of the well when you throw a stone into the well. So this is the scenario only. Okay, scenario. This is a gravitational effect lah. Okay, gravitational effect. Where the time is when the t is time, so the time variable is t and g is the constant value 9.81. Okay, 9.81. Okay, so what you can do is you can type the coding in the scipad. Okay, scipad and execute from here, or you copy this one into the this. Okay, so this is what I'm going to do lah. Okay. So make it smaller because it's quite big. Okay, alright. Okay, so first of all, you need to declare the time. Okay, why? Because time is one of the input to calculate the D, right? Okay, and G we know that it is constant, so you need to list the T value. Okay, list the T value. Okay, so we are going to declare the array lah. Okay, array. So how we declare the array? How we declare the array? So t equals to itulah. Okay, quite simple. 1 to 10. Okay. Okay. Or we don't want to put the semicolon there. So this is how the answer will be. Will looks like 1 to 1, 2, 3, 4, 5, and then in the browser, variable browser, you can see that the variable t has been declared, and from here you can see the values of t. Yeah, simple like a MATLAB. Okay, all right. Then you need to declare another constant value, which is g, right? Which is 9.81. Okay. So the Scilab will give you this value. Okay, now you are ready to compute the D. Okay, so simple. So how we convert this equation into the Scilab syntax? So how we do that? Okay, that's why I introduced you to the specific syntax just now. Okay, so now we are going to use that syntax. So D is the output. Okay, 1/2, half. Okay, half multiply is asterisk. So you need to use the asterisk symbol lah. Okay, G is the input variable multiply by T. So T is in array. Okay, array. So that's why you need to put the dot there. If you do not put the dot, it will give you errors lah. Wrong answer. Okay, and this is the power of 2. Okay, so you will get this value. So you need to be very careful. You need to know what you are dealing with, and please be very careful when you are handling the array, matrix, or vectors. Okay, because you need to use the proper syntax for the array, vectors, and matrices. Okay, so this is the answer. Okay, easy, right? Okay, so we solve question number 1. Okay, number 1 already solved. Okay, so number 2, determine the time taken for the stone to hit the bottom of the well if the depth of the well is 1000 meters. Okay, now we know the values of D. We need to find the T. So how you do that? So we need to rearrange this equation and write in terms of Scilab syntax. So how we are going to do that? Okay, very simple. Only 2 lines. 2 lines. 2 lines codings are needed. Okay. Okay. So first we need to declare the values of depth of the well. Okay. To T equals to 1000. So now we want to find the T. Okay. So T means that 2 multiplied by T divided by G, all of this must be square root. Correct? Okay, so that's why. Is that correct? Okay, ceiling. We put ceiling there. Okay. Okay, let's say if we do not put ceiling. SQRT multiplied by 2 multiplied by D divided by G. Okay. Okay. And if you put ceiling, it will give you the ceiling value lah. Okay. Like that. Rounding to the nearest one. Okay. 14.27. The highest one, highest one to 15. Okay. Okay, so what else? Okay, so for the plotting, so since that in engineering we need to do a lot of plotting. Okay, so these are the example of the plotting of the sine and cosine signals. For the signal and system lah, very easy. Okay, so I just copy here. You can directly execute here actually, but I just want to show you lah. Okay, just want to show you this one. Okay, so this is how the plotting of the trigonometric. So you have how many graph you have here? 3 graph, right? Sine, cosine, and sine 2t. Okay. So in the Scilab, you also can do the plotting. Okay. Like this lah. Okay. Alright. If you need to plot logarithmic, piecewise, linear, and so on. So various of plotting. Okay. Various of plotting. So it will give you like this lah. Okay. See, I did not clear. Okay, sorry. Let me clear. Okay, so to clear the coding, clear the console, just clear like this, and again copy paste. Oops. So need to. Okay. Right. So please make sure that you clear the name first lah, the figure. Okay. So this is how we plot the piecewise linear logarithmic graph, piecewise constant, and vertical bar. So you can explore more on how to plot the, let's say you want to plot the histogram and so on. So you can use the Scilab. Okay. Okay, so yeah, another example is this one. Okay, so we delete this first. Okay, and yeah. Okay, so you can do, what's this? So this is the histogram, right? And this is a 2D plotting, and this is the normal graph lah. Okay, and you can do the polar plot also in the Scilab. Okay, it's interesting. Okay, so I think that's about it for the Scilab. Yeah, since this is the webinar is to introduce and get you more engaged and also motivate you to go further and start using the Scilab. So if you have any question, then you can ask me now. Yeah. So do you have any questions?
Thank you so much, Dr. Hasliza, for the sharing of the Scilab for today's webinar. Before